Hi everyone. In this video, we're going to talk about the Monty Hall problem. It was a problem which originated from this game show, which called Let's Make a Deal, and it's based on this guy named Monty, which was the host of this game show. So in this video, I'm not just going to share the problem, but we also going to talk about the solution of the problem using some probability. Okay. So let's get started. So let's first talk about the Let's Make a Deal show. Let's Make a D show was hosted by the Monty Hall and Carol Miller in originally ran from 1963 to 1967 on network TV. The highlight of the show was the big deal, where contestant would trade previous winning for the chance to choose one of the three doors and take whatever behind it. So there are three doors in this show, and behind one of the doors is a car, and the two doors are have a livestock, which Monty used to call zongs. Okay, let's make a deal. Inspired a probability problem that confuses and eager the best mathematician, even Paul Rods. Paul Rods is a 20th century mathematician. He's a Hungarian mathematician. So suppose you are a contestant on Let's Make a Deal show. This was the original photo taken from the show. You asked to choose one of the three doors. The grand prize is behind one of the doors, and the other two doors hid silly consolation gifts, which Monty used to call zongs. Okay, basically, what happened is, let's imagine there are three doors. Okay, and you chose the first one, and Monty knows where the car is and where the zongs is. So he will come and open one of the doors. Okay, let's suppose he opened the third door because he chose first, and he has to open any one of the other doors, any one of the other two doors. So the question is, should you switch? Assuming that you chose the first door, and then mod shows that the third doors have a honk behind it, should you stick with the choice of your first door, or should you choose the second door, which may have a car behind it, or not? Answer is yes. You should switch always. Assuming that Monty always give you a chance to switch, you double your odds of winning by switching the doors. So if you Monty give you a chance to switch, you should always switch because it will double your odds of winning by switching the doors. Okay, we will see why first by looking at the possible cases, then directly computing the probability of winning with each strategy. Okay. So now let's look at all the possible cases. The first case which have the price behind the first door, the second case which have a price behind the second door, and the third case which have the price behind the third door. So these three cases will be the possible combination where the price has been placed, and we going to talk about all of these and find out the probability of winning. Okay, so let us assume that he chose the first door in all these three cases, and Morty has to open any other door other than the first to show you a honk and ask you the question that do you want to switch or not. Okay, in this case, Morty may open either the door second or third because both, as you can see, the prize is behind the first door only, and the second door and the third door both have honks behind it. So he can open the second door also or the third door also. In these both cases, Monty don't have a choice. He has to open the third door in this case and the second door in this case, because if he cannot open the door with the price, so he will open the third door in this case and the second door in this case. Okay, and show the zonk only. So what happened when you switch? In this case, if you switch to second, you were right the first time, and you will not win. You will lose. Okay. In other two cases, if you switch to the second door in the second case or the third door in the third case, you will win the prize because the in the second case you choose to switch to the second door, and the third case you choose to switch to the third door. You will win the prize, and prove this result without listing all the cases, we need the notion of conditional probability. So we're going to use conditional probability here to prove this result. Here, if we have chosen the door first and Morty have opened the door second, would you like to know the probability that the prize is behind the first door and the probability that the prize is behind the third door, given the additional information? Additional information is that Monty has opened the second door. Okay, so let's see the maths and work on it. Uh, we can determine the probability using the rule. This rule is called Beer's rule in probability. In words, the probability of event A given event B is equals to the probability of both A and B divided by the probability of B. Okay. And the following argument, assume that we originally chose the door first. Monty has opened the door second. Okay, about the notation. Let's hashtag one denotes the event when the price is. So now let's talk about the notation. Let's hashtag of one denotes the event that the price is behind the door first. So hashtag one will represent the event when the price is behind the door first, and similarly with the hashtag two and hashtag three. And open hashtag 2 denotes that the event that Monte has opened the second door. Okay, our aim is here to compute the probability that the price is behind the door first, given that the Monte has opened the second door. Okay, and the probability that the price is behind the third door, given that the Monte has opened the second door. Okay, so this is the base formula as I told you about. And we use this conditional probability formula to find the probability of this and probability of this. Okay, and it can be written by like this. As you can see, if this is hashtag one will be A and open hashtag two will be B, and you can write it like this. Okay, this is the second rule, which can be achieved just by multiplying the probability of B to the probability conditional probability of A and B. Okay, you can just now let us compute both these probability. And first we will look at the numerator and compute it, and then we will compute the denominator and find the total probability. For the numerator, we are using the rule 2, and using those rule 2 we can write it like this, which is the probability that the price is behind first, and the probability that he opened the door second will equal to the he opened the door second and the price was behind the door first, multiplied by the probability that the price is behind the door first only. If the price is behind the door first, Monty can open either second door or third door. So the probability that the he opened the second door when the price is behind first, it's half, because he can open the second door also or the third door also. And the probability of that the price is behind first door will be one third, because there are three doors and the probability that one of them has the price will be one third. So the total probability will be one sixth. So like this only, we're going to compute this numerator also and find the probability. For this, the probability that the second door is to open when the third door have priced, and into the probability that the third door have priced, it will be one third as we know. And this probability will be 1, because if the third door have the price and Monty knows that, then he has to open the second door, because he cannot show the price to the winner. So the probability will be 1. So now we have found the value in the numerator, and it's now the turn for the denominator. So for denominator, we're going to consider all the cases for the opening of the second door, and we're going to add them and find the total probability, which will basically be probability of when the second door is open. It will be equal to the probability of second door is open when the first door has the price, the probability of the second door open when the second door have the price, and the probability of the second door open when the third door had the price. Okay, so probability of the second door open when the first door have price is one sixth, because as you can see in the repeater, these both are the same thing, and it will be one sixth as we found out in the previous slide. This will be zero, because if the second door has the price, then Monty cannot open the second door, and it will be zero. There will be no case like this, because he cannot open the door with the price. Okay, this probability we also found out right here, which is one third, and to put this in the equation here. Okay, one third, and the probability of that the second door will be opened will come out to be one sixth plus one third, which is equals to one half. Now when we know the value of numerators and value of denominator also, we can find out the conditional probability of both these cases, uh, when the price is behind the first door and when the price is behind the third door. So the first case, when the price is behind the first door and Monty open the door second, will be one sixth by one two, which equals to one third. And the second case, when the price is behind the third door and Monty opened the second door, will be 1/3 by half. Okay, which come out to be two third. So as you can see, in the first case where the prize is behind the first door and Monty opened the second door, will the probability is lesser than the uh, case when you switch to door number 3, and it's half of the probability when you switch. Okay, so if in this Monty Hall problem you have given a choice, you should always switch to another door because your probability will increase of getting the prize. Okay, so let's conclude this video. Now we understood and proven that the probability will increase if we switch the door. Conclusions. Switching increase your chances of winning by two-thirds. The result hold true for and doors. About the video, and that's about the Monty Hall problem. Thanks for watching. Please like, share, and subscribe. Thank you.